Hello, my friends. Today we're going to talk about equations of circles. Before we go ahead and get started, let's go ahead and talk about where the equation of a circle comes from. So when we say we're talking about equations of circles, that means on the coordinate plane. So we're going to graph them. So it's kind of like when you were in Algebra 1 and you were graphing lines and it was y equals mx plus b. So on the front of your foldable, you have this, x minus h quantity squared plus y minus k quantity squared equals r squared. That looks a little complicated, Mrs. Howes, but the thing is, guys, it's not that complicated because it actually comes from something that we are already familiar with. So let's look at this picture of a circle. So I have this point right here, which is my center point. We're going to call that HK. That means it can be any center point, any numbers. We're just going to let H and K represent some random numbers. And then I also have another point that's on the circle. That point is going to be called XY. Again, that's any point that can be on the circle. The distance in between them, we're going to call R, or the radius. And so this radius, I need a way to represent it. Well, if I find the horizontal distance and the vertical distance, what kind of shape does that make? Yep, it makes a right triangle, which means that the radius is actually the hypotenuse of that right triangle. And in order to find the lengths of sides, I can use my a squared plus b squared equals c squared. So if I would go ahead and call these A, B, and C. So I'm going to call this side right here A. I'm going to call this vertical side B. And of course, I'm going to call the radius the C. I need a way to represent them with my H and my X. Well, if this part right here was at 10 and this part was at 3, how many units would be in between them? 10 minus 3 is 7. So there'd be 7 units in between them. So if I have X and H, the amount of units in between them would be X minus H. It would be them subtracted. Same thing for the Y's. I would do Y minus K for the Y value. So since I'm calling this side A, in place of this A, I would write X minus H squared. In place of this B, I would write Y minus K squared. And the c squared, of course, is r squared. And that's where it comes from. It comes from the Pythagorean theorem. It also makes sense because the Pythagorean theorem is also where the distance formula comes from. Do you notice how this feels and looks very similar to the distance formula? It should. And that's because the circle, the literal definition of circle, is the set of all points that are equidistant from a given center point. All right, go ahead and open up your foldable and let's go ahead and take a little bit of notes. So on the inside, I have my equation of my circle. Let's review what we just talked about. So what does this H represent? Well, H represents the X value of the center point. The X value of the center point. The K represents the Y value of the center point. And then the R is, of course, the radius. Remember, if at any time you need to pause the video, you are totally welcome to do so. All right, let's do a couple of examples. So first, we're going to identify the center and the radius given the equation. So here I have an equation. It's all filled in for me. I have x minus h squared plus y minus k squared equals r squared. So I have 4, 5, and 100 in place of my h, k, and r. So let's go ahead and figure out which one is which. So first of all, the 4, that represents the h. The 5 represents the k. And the 100 does not represent r, but r squared. There is a little bit of a difference. All right, now I remember the thing that we just talked about. This one is x minus h, but there's a plus sign there. And because there's a plus sign there, what made that a positive? Well, two negatives make a positive. So that means that that center x value is actually -4. And then the y is y minus k. Well, since the minuses match up, that means that my k value is just 5. So it really looks like the signs that are here in the center are the opposite of the ones that were written in the equation. And yeah, that actually makes sense because remember in my equation it says x minus h, y minus k. And remember, minus really means the opposite. And negative is like taking the opposite of something. So that makes sense. All right, my radius, r squared, is 100. So since r squared is 100, how do I get r by itself? Well, a square root undoes a square. So the square root of 100 is 10. So my radius is 10. Okay, look, we did it. Let's do another one. Same thing. So start by identifying your h, k, and r. So x minus h, so 1 is your h. Y minus k, so 6 is the k. And the 49 is r squared. So since it says x minus 1 and it's x minus h, that means my center is positive 1. And since it says y minus k, but it says y plus 6, that really means that it was minus and negative, so it's going to be negative 6. R squared is 49. I have to take the square root of both sides. So the square root of 49 is 7. So the center of this equation is at 1, negative 6. And the radius is at 7. All right, let's do a couple more examples. So we're going to go ahead and be given the center and radius this time, and we are going to write an equation of a circle. So same thing, let's start by identifying what we know. So we were given that the center is at 1, negative 3, and the radius is at 4. So 1 is my h value, negative 3 is my k value, and the radius 4 is r. So let's plug it in. So it's x minus h, so x minus 1, y minus k, so y minus negative 3, and the radius is 4. So now I can go ahead and simplify everything. So right here, I can't simplify x minus 1, so that stays the same. But when I have minus and negative, remember that becomes plus. Two negatives become a positive, so it becomes y plus 3. And then 4 squared is 16. Hey, we did it! All right, let's try another one. So let's go ahead and identify what we were given. So the center is at negative 1, 0, and the diameter this time is at 10. So my h is negative 1, my k is 0, and my r is, well, we don't know, but we do have the diameter. And what do we know about the diameter and the radius? How are they related? Well, the diameter and the radius are related because the diameter is double the radius. Or you could say the radius is half the diameter. So that means that if I know the diameter is 10, I just divide it by 2 to get me the radius, which is 5. So now we can go ahead and plug everything in. So it's x minus h, which we know is negative 1, y minus k, which we know is 0, and the radius is 5. So when I simplify it, minus a negative becomes plus. And what happens to this 0? Well, I actually don't have to write it because whenever I have a plus 0 or minus 0, it's not going to change the value in any way, shape, or form, which means that I can write it like this. X plus 1 quantity squared, because remember this plus. Y squared, I don't need to write the 0, equals 25, which is 5 squared. So remember, whenever you have an x squared plus y squared, if there's no h and k, that means that those values are 0. All right, let's go ahead and try one more problem. We're going to write an equation of a circle with the given information. So I was given that the center point is at 2, 3, and a point on the circle is at negative 2, 0. So go ahead and start by labeling the things that we know. So I know that 2 is my h. I know that 3 is the k. I wasn't given an r, but let's think about this for a second. This is just like the problem that we talked about at the beginning of this video, where I'm talking about a point on the circle, and we called that one xy, so we're going to call this one the same thing. So now let's go ahead and get our equation set up. So here's our equation that is the formula, the general formula, and I want you to see that we don't have a radius. That's what we need. So what we're going to do is we are going to go ahead and take these things that we have, hk and xy, plug them in for the x, the h, the y, and the k here, and we're going to solve for r. So I'm going to go ahead and say x minus h. Well, x is negative 2 minus h, which is positive 2. Y is 0 minus k, which is 3. And I don't know what r is, so I'm going to leave it there. So now let's simplify. So negative 2 minus 2 is negative 4. 0 minus 3 is negative 3 equals r squared. This should start to look familiar to you. Does this start to look like the Pythagorean theorem? It should, because it comes from the same thing. Remember, this comes from the Pythagorean theorem. So now we just got to simplify it. So we're going to do our exponents next. A negative times a negative is a positive. So negative 4 times negative 4 is positive 16. 3 squared is 9. And 16 plus 9 is 25. And I actually could technically be done, because remember, we just need this part up here. We need this r squared, right? And look at what we found. We found r squared. So technically, yeah, we're done. We only need that 25. But if you wanted to go one step further, we could go ahead and take the square root of both sides, which would give me the radius of 5. So I'm going to write x minus h, which is 2 squared, plus y minus k squared equals 5 squared. So let's simplify it. These two things right here, minus 2 and minus 3, can't be simplified, so I'm just going to rewrite them. And 5 squared is 25. Nice. All right, just a couple more examples to go. All right, we're going to write and graph an equation of a circle given the graph. So I need to identify the same things that I was identifying before. I always need the center and the radius. So the center is right here in the middle. The center is at, let's count it, 1, 2 to the left, so that's negative 2. And it's up 1, 2, 3, 4, so it's at negative 2, 4. The radius, I can draw it in any direction I can count. So I can draw it to the left and right, or I can draw it up and down. So I'm going to draw the distance from the center to the side. And let's count it. That is 1, 2 units. So my radius is 2. So let's go ahead and do it now. So my h is negative 2, and my k is 4, and my r is 2. So I'm going to write x minus negative 2 and y minus 4 equals 2 squared. So simplify. So negative and a negative is a positive, plus 2 squared plus y minus 4 squared equals 4. All right, last example. We're going to graph the equation now. So let's go ahead and get the information from the equation that we now need in order to graph. So it's the exact opposite of what we just did, but we still need the same thing. So the negative 3 is my h, the negative 1 represents my k, and the 9 is r squared. So for my center, Remember, since it says -3, that means the center is at +3. Since it says -1, the center is at +1. Remember, it's the opposite of the sign. And then for the radius, since I know that r squared equals 9, if I take the square root of both sides, r is equal to 3. So the radius is 3. So we're going to start by graphing the center point. So I'm going to go over 3 and up 1. And there's my center. Now from there, I can count my radius. Now I have to keep counting my radius multiple times, and every time I'm going to come back to the center point. So I'm going to go ahead and count 3 to the right. So 1, 2, 3, and I'm going to plot my point right there. And I'm going to do the same thing up to the left and down. So I'm going to count up 3, 1, 2, 3, and plot my point. I'm going to count to the left 3, 1, 2, 3, and plot my point. And then count down 3, 1, 2, 3, and plot my point. Now, do I have to draw the little bumps every time I count? No, but it does help, and it's also a really good visual representation of what's going on. All right, just a little tip about how to draw your circle, because I have seen a lot of circles to get drawn like this. Is that a good circle? No, it kind of looks a little bit like a square. So what we need to do is, when you're drawing your circle, just a little tip, is start by drawing some really broad, kind of flat looking arcs. And then you can kind of connect them from there. And I have found that if kids do that, they're going to be a lot less likely to make it look like a diamond. It should look like a circle, not a diamond. So there it is. Oh, not bad. All right, my friends, let's go ahead and get practicing.